My name is Łukasz Sosnowski. I'm from the System Research Institute at the Polish Academy of Sciences. But today I will present a paper from the R&D project. My presentation is about artificial intelligence in personalized healthcare analysis for women's menstrual health disorder. This is a this is a project co-financed by European Union Smart Growth Operation Program 2014-2020. This is the agenda of my today's presentation. For the very beginning, we have the two projects. First project called Overfriend 1.0 is already finished. We can here we can see that what was the starting point. The first project was about making AI algorithms for ovulation detection and prediction of the ovulation. Some cycle labeling based on fuzzy linguistic summaries, and so on and so on. We already did it. It was between 2018 2020, and the effects of the Overfriend 1.0 was the starting point to our current project, current R&D projects. Called Developing Innovative Solutions in the Domain of Detection of Frequent Intimate and Hormonal Health Disorders in Women of Procreative Age based on Artificial Intelligence and Machine Learning. The starting point takes effects of the previous projects, and we have some new data. We have about 700,000 menstrual cycles to process, and some new tools like mobile application for collecting data and so on and so on. And these projects we are working from 9 months, and we already closed the first stage, and after the first stage we have designed and developed prototypes of the detectors for some disorders like a PMS, LPD, polyps. I will talk about this a little bit later. We prepared first labeled reference set to make evaluations, some medical concepts, definitions for disorders, and we already did evaluation for the first stage. And so what is the main goal for our current project is to predict vulnerability to a specific disorder, which culminating in the recommendation of the medical visit with specific specialty. So we don't want to make a diagnosis like medical doctors do, but only give a chance for women, for our users in the application to make some medical examinations to and maybe tell our users that there is a vulnerability or there's a risk of having such disorder, like I already said. So we are studying 3 main areas in our projects. ABC. So as a part of above mentioned areas, we deal with polyps and fibroids, LPD, so luteal phase defect, PMS, PMDD, PCOS, and so on and so on. The bold one are that we described in our paper. So we just focus on these 3 disorders. And for today's presentation, I selected one to describe because of the time. And about the context, medical context, we are talking in the projects about menstrual cycles, fertile windows, ovulation, and anovulatory cycles. So when you are reading our paper, this is the definitions, the concepts which should be already known. What type of data we have? We are using for the first stage, when we would like to designate the ovulation, we are using BBT, so basal body temperature. So we need that our users measure temperature or make some other observations, like, for example, cervical mucus observations. We have prepared 5 states of the cervical mucus, and our user women have to just select the correct one in application for the current day. And we have a lot of other data, for example, subjective symptoms near 100, like ovarian pain, sensitive breast, increased libido, and so on. And all that data we combine, and we build time series data for the cycles. But what is important, all of that data are declarative data. So these are observations which, of course, uses given scales, but maybe incomplete, noisy, and subjective. So 2 women can have the same symptom, but can enter a little bit different data in an application. And our data is, we built something like that. So we have time series indexed by the day of the cycle. So from the first day of the cycle, and then each line like this are the different type of data. So for example, the temperature, cervix mucus type, or bleeding, and some other symptoms. And this is multivariate time series, so it's quite complicated for processing. And here we have overview of the platform. So everything starts with the mobile application, where user can select or can put data which coming for our data warehouse. Here we have platform Ovofriend 1.0. So from the first project, where we processing that data, and we designate ovulation, make some labeling. So we are designating some concepts from the time series, because we are using here concepts or labels or granules. Let's say granules, which we compute from the time series to later make processing based on granules, not directly from the time series. Then we are checking some border conditions which are different from for each disorder. So we are looking for a special kind of symptoms, special kind of labels already designated, and if it's fulfilled, then we start more detailed analysis. So we need to activate one of our analysis activators, and then we try to to know a little bit more. So we try to get some more data from the user, from women. We show in the application some additional surveys, of course, depending on the type of the disorder, and we are trying to investigate and designate some more, let's say, medical concepts. So that's granules or that labels. These are fuzzy medical concepts, fuzzy labels. So they can have the strong or the power of the label from 0 to 1. And but we are using not all the value, but 0, 0.33, 0.66, and 1. And okay, that's only the overview. So after the calculating and gathering more data, we make some algebra of the fuzzy medical concepts and try to build some kind of ranking. And I will talk about this ranking a little bit later. Right now, this is the general scheme of each prototype of this tree, which was described in a paper. So we are starting, of course, in the first step. We have the data collection and processing. So we are taking from the data warehouse cycles and data input by the users. We getting already detected or not, detected ovulation or or information that is the anovulatory cycles. We make some another aggregation, and we are using such concepts, such labels, such information granules. That information granules, or in other words, labels are organized in a 3-level hierarchy. And we have the detectors level concepts, which are concerning only one type of data. One detector is one type of data, so about only temperature, about only mucus, or some other kind of data. The second level is a concept about whole cycle. So we have more general information about cycle from the beginning to the end of the cycles, but this information we can calculate after closing the cycle. So when we know that that cycle is already closed. And the third level of the concepts or the granules or labels is user concepts, where we look backwards couple months, so for example 6 months back, and try to analyze the nearest history of current user or the some similar user. So we are calling the profile. The profile is the set of the similar users, which we are already have calculated. And after getting that information, that data, we for each disorder have prepared the special goal functions, which we are and we can calculate some scores. So we are giving scores for existing any special label what we are expecting, and after that we summarize all the score, and then we can prepare a ranking of the cycles or the users. And after that, in the decision point, we firstly have calculated suboptimal thresholds learned from the labeled data, and then we know if the final score is behind the thresholds, then we are interpreted as a negative negative case, and above, this is a positive case. And about the concepts, hierarchy and the labels. Now we have 332 labels organized into 3-level hierarchy. After the first project, we had it less than 100. So as we can see, it's growing, but this is the much better representation of the cycle than the time series, because time series is quite costly to process, and after reorganize the data, after calculating such kind of granules, we can make processing based on that granules, and this is much faster. And as you can see, there are a lot of information. So, for example, in the detectors level, for example, the information about one type of the data. For example, the not double phase in the temperature. For example, we focus that there's not double phased cycle, and we just designate that concept, and now we starting to use it. We don't have to each time recognize that it is double phase or not. So it's very fast. And on the middle level, we have information about whole cycle. So for example, intermenstrual bleeding. So we checked all the cycle, and we know that after the menstruation there are some bleedings or some spottings inside the cycle, and we again we don't have to we don't need to analyze it case by case or each time, but only once we designate such concept, and after that we are using that concept. Of course, the concepts have its power, so it can be few, so 0.33 or a little bit more, or very a lot of bleeding, so then it will have one. That scale we are already learning from data using our reference set from our medical experts. And this one tool which are using medical experts. This directly from it comes from PMS. So our medical experts uses such a tool for tagging. So they have all the information about the cycle. So here we have the temperature, here we have ovulation, bleeding, mucus, cervix, intercourses, and so on and so on. A lot of other data, moods, symptoms, which are already seen here. And after that, our experts return to us the information that there is a vulnerability of or risk of existing the PMS or not, and in what is the chance. So they can write the value from 0 to 1, and we are collecting it, and we are building the reference set. The reference set is drawn, so the cycles for tagging are drawn, and we are trying to drawn from two types of data. One set is that's already existing some features or some attributes where are where we are thinking that they can tell the expert that there is something connected with the PMS, for example, like here, but in the other one without these attributes, because we are trying to get the balance set. And now we have the complete scheme for the calculating LPD risk vulnerability. In our paper, there are 3 of them, but because of the short of the time, I chosen that one because it's quite simple. So firstly, in LPD, we have to process only ovulated data, ovulated cycle, because when we have the unovulated cycle, then there is no luteal phase. So, but the LPD, it is the luteal phase disorder or failure. So, of course, the luteal phase must exist. And so we get the information or get the status of the ovulation. Then we are calculating the boundary conditions. And the boundary conditions here are that firstly the length of the luteal phase must be enough short, and then we select relevant circular concepts, which are telling us some more information. Firstly, luteal phase length, intermenstrual bleedings, which are important, but intermenstrual bleedings, especially in the second phase of the cycle, so in the luteal phase, some information about miscarriages in the history, and long trying time, trying to conceive in a long time. Then we are calculating score for each cycle, and after that we are building the ranking. If the current cycle score is enough high, then we assign the LPD vulnerability label. And this is each for each cycles. And to get the final label for user, we have to analyze the nearest history and look at the nearest history that has the enough labels of the vulnerability. So we are checking for n months and then enough labels. And here we have example of the goal score, which is using for building ranking for LPD, for anatomical changes. Of course, they are all similar. So we have some weights and we have some information calculated from the labels, from the concepts. Of course, all the information what we need to get comes from the medical experts, and of course they are different between disorders. For the training set, we learn the dress codes for on that set, and on the rest. So 67% cycles we were testing, and for each time we saved all the contingency tables, so true positive, true negatives, false positive, false negatives. And after that, at the end, we sum up that values, and then we have calculated average measures like accuracy and F1 score. As we can see, it is nearly about 0.9 or 0.8. It is enough for us for the first stage because then we were working with that data again, and we will add some features. To conclude, what is important in after that first stage, after that work. Firstly, the data granules, which are a very strong tool for processing big data. So we can process a lot of cases, a lot of data, a lot of situations using only that granules, not to look into directly time series, which are very costly. We achieve good enough results from the first stage, and in the next stage, what we will do now, we are selecting user using that prototypes from the first stage to perform medical examinations and share the result with the projects, and then we will make an inclusion the result of the medical examination into the reference set to improve the quality of experts' judgment from the first stage. Because first stage we built the prototypes that learned how the experts thinking about the data and how they are tagging it, and now we have to check that if they do not make errors. And I have no time more. So.
Unfortunately, yes.
Yes, so just some other material. If you are interested in the topic, I put some literature, and that's all. Thank you.
Thank you very much. Just real quick, also for everybody else, when you have 3 minutes left, I show this card, so maybe everybody can try to look at me once in a while too. And if it's really too long, then Olaf will say something. But thank you very much, Łukasz. And we already have one question in the chat. I don't know, Sarah, do you want to ask it yourself, or I don't see if your microphone is. Otherwise, I just read it out real quick. She wrote, I assume that the data is fully based on a voluntary input from women, and everybody might feel these attributes differently. For example, being nervous or being stressed. Do you take this into account by adding a specific uncertainty? And how do you treat when someone forgets to correctly monitor the cycle?
It's divided for 2 steps. So firstly, the main information is so the data to detect the ovulation. And if we have too less data for detect correct ovulation, we have something which is called intelligence communicator. So we ask some more questions to our user to be certain that especially that or other data are correct or not. And or there is no some data, and we try to get that data. But of course, there is a problem with the uncertainty, like in that example. So being nervous maybe interpret differently by one user and another. But these data are just for that are not the main data. That's only additional data which we can take into account or not. So that's why it's not so important in such a case.
All right, thank you. Just for everybody, I asked the FETSIS committee so we can stay in this WebEx a little bit longer. So everybody will have the time that is on the schedule. So don't worry about this. Is there another question for Łukasz?
Yes, hello. Good morning. I have a question. You are currently able to assess the symptoms and risks of LPD or PMS, among others. And I was wondering, do you plan to expand the variety of these diseases in the future so that you can detect also other diseases with your application?
Maybe yes, but we are in the R&D project, which is already has static list of the disorders. For in the project, we just we can just look into such disorders like I already showed. But of course, after the project, that way that we already discovered, I think it's promising and it can be used for others disorders always, not all, that other disorders as well.
I have a question. In the paper, especially for PMS, you mentioned those mood symptoms, which can be selected. So first of all, how were these compiled, and can the users expand the catalog? So can they add, is there like a free field or something? Can they add some mood system?
This is the, available in the application. So in the application, you have a special window which you are entering, and then you have the whole list, and you can tap on the special mood, and so at the one time you can enter 1, 2, 3, or all the moods.
Okay, but you can't add another one.
Yes, that's the fixed list.
Okay. Then thank you very much. Do you see one?
Okay. Maybe I add a little one sentence. That application is already available on the store. So you, if you go
so
to the store, you can download it. It is in iOS and in Google Play as well. Just write OvoFriend and you can download our current version of that application.
All right. Thank you.